Alright, we're looking at GSRT, Objective 1 still. This video will deal with Worksheet 4 in particular. And the essence of Worksheet 4 is all about centers of dilation. And so in the previous worksheet we worked specifically with the idea of the movement of and formation of new lines. So we learned there that if you were on the outside of the line, you would form more lines or more segments. Now, what I like about this particular item is that it's going to show you the different kinds of formations that take place when we dilate. So let me show you this idea. So here we are at O. We're going to dilate triangle ABC by a scale factor of 2. So what that means is I'm going to draw my rays through OA, OB, and OC. And in doing so, we form our directional rays. Now, before I was kind of with my ruler just estimating things. That's the best way to handle dilations, is to think of it as slope. This is an early concept I want to develop with you. And so a dilation of 2 means to get to A, I rose 2 and I went 3. So to get to 2 times that, I would do it a second time, up 2 over 3. So here would be A prime here. Notice I was using the slope. If you start to get at the idea that if you multiply it by 1, you get the first slope. If you go 2, you get 2 slopes. Multiply 3, you get 3 slopes. So B looks like we go over 1, 2, 3, 4, and up 1. 1, 2, 3, 4, and up 1. Here is B prime. Again, I'm not estimating. This is exactly where these locations are, and C prime is here. So if I pull out my ruler now and connect the dots, connect these vertices, I will have created a dilation of 2. Now, again, what I want you to notice here is that this here, this line right here, is parallel to this one right here. Kind of interesting, isn't it? And if we grab a different color here, you'll notice that this line here is parallel to this one here. Again, do you see how that early idea of a dilation, how it creates, because our center is out, it creates those kinds of things taking place there. And then if we come over here now, notice we are inside. So how do we dilate? Well, it's the same process. We dilate from center O and we create a ray from O through each of the vertices that we're going to move. And so here I go through C. And again, this seems to be the same scale factor of 2. So A is 1 up, so A prime will be 2 up. B is 1 to the right, so B prime will be 2 to the right. And then the slope to C is left 1, down 2. So I'm going to go left 1, down 2. Here is C prime. And this creates kind of a very cool, like, I call it the vortex look. Kind of one inside of the other idea. And again, you're learning the characteristics of what these look like. If you have one off to the side, you tend to cast kind of like the shadow idea out this way. If you're inside, you're going to create either, it's going to shrink in or shrink out. And again, let me just go back to that same idea for just a minute here to talk about the idea of where these parallel lines are. So here again, this segment from A to B finds a parallel partner when you're all done. Dilations are all about parallel lines, so keep a real close look on that. Alright, let's just finish up the other dilations. What happens if your center of dilation is on the line, like or on the triangle like A is? Well, then it moves nowhere, right? A goes nowhere at least. But C will still be dilated twice. So 1 over 3 down, 1 over 3 down. Here is C prime. B is 1 over, oh, we need its ray. I forgot to draw its ray. So there's its ray. Over 1 down 1, over 1 down 1. Here's B prime. Now again, we see that parallel line environment taking place in that dilation. This picture right here is the classic picture coming up later in similarity. You'll see that one coming. Alright, and then the last type of thing is a negative scale factor. Ooh, I like this one. So negative means to go in the opposite direction. So you notice I'm creating rays not purely out towards, just towards the original points. I'm actually extending the rays in the opposite direction as well. Because what a negative does, like a -2, sends it out the opposite direction, opposite ray. So to get to A is up 2 over 2. So I'm going to do that twice. 2, 2, 2, 2. Here is A prime. Because not only is it negative, meaning going this direction, I'm going to double that. So C is over 1 down 1, so I'm going to reverse that to get C prime. B is up 1, 1, 2, 3, so I'm going to go down 1, 1, 2, 3, down 1, 1, 2, 3. That line was just a little bit off there, but we found it through slope, and here is our shape. Now, a cool thing happens here. This is something you'll investigate a little bit. Take a look. A kind of a cool thing happens. Is that a reflection? Is that a what on there? Anyways, now the last thing it will ask you to do is to determine the center of dilation, and the way that we will approach that is the reverse concept. In other words, we know that A and A prime have to be on a ray together. I don't know where the center is, but I know that the center has to be on that ray or line somewhere. I know that B to B prime also has to go through each other on a ray, and C prime also have to. So that's actually a very easy kind of reverse concept. So the center is at 0 and 2, looks like. Now, how do we figure out the scale factor? So we look for our primes, so we see B prime, C prime, A prime. So it's obviously a larger scaling, an enlargement. And I can use slope to help me. Slope is up 2 over 3, up 2 over 3. 2 slopes took place. This is a scale factor of 2.